Okay, now as you can see within the document, the next question that we want to address is the change in velocity of a 100-gram mass subject to a net force of 400 newtons for 1 millisecond. So 400 Newton force acting on a 100-gram mass, which is a tenth of a kilogram, is going to give it a pretty tremendous acceleration. But if that acceleration only lasts for a millisecond, the change in velocity might not be all that great. Well, we use the impulse momentum theorem. We don't bother finding the acceleration and seeing what the acceleration times the time interval would be, although in this case that would be a pretty straightforward way to solve the problem. But we want to solve the problem using this new idea that impulse equals change in momentum. So what do we know? We know the net force and we know the delta t, so we get the impulse. Okay, so our impulse is Fnet delta t is 400 newtons times 0.001 second, and it comes out to 0.4 newton seconds. So that's what your m delta v is, and that can also be expressed as 0.4 kilogram meters per second, breaking the units down to the fundamental units of kilograms, meters, and seconds. So m delta v is 0.4 kilogram meters per second. Delta v is 0.4 kilogram meters per second divided by m. Now this m is not the same as this m. That's an m unit. This is mass. When we divide by the mass, which is 0.1 kilogram, we end up with 0.1 divided into 4, and the kilogram divides a kilogram, leaving us meters per second. So now we know the change in velocity. So it's a very straightforward application of the impulse momentum theorem.